All right, so we're going to look at this problem, which we're going to test the claim about the population mean. So we have a population mean of 40 again, but we have an alpha of 0.06. And what we're going to do is we're going to count, we have a population standard deviation of 3.08. We have our sample mean of 39.2, and we have n equals 58. So the claim is an equality. That means our null hypothesis is mu equals 40, and our alternative is mu does not equal 40. This will be a two-tailed test, and what we're going to do is we'll set all of these things together. So let me copy all of this stuff down. It's very similar to one of the previous problems I had done. So let's go through here. So we'll claim mu equals 40. Let me bring all the data over from this. Yep, good. And let's get the data. So mu equals 40, alpha equals 6, and the standard deviation, so alpha 0.06. Yep. Our population standard deviation is 3.08. And we go to measure it, and our sample give us an average of 39.2 and an n of 58. 39.2, and we took 58 samples. So our null hypothesis is the claim. Our alternative hypothesis is the inequality, which means we'll be looking at a two-tailed test. And our rejection region will be the tails that split the 0.06. So we're going to have a 3% region in there. And so what we're going to want to do is we're going to calculate our test statistics and go from there. So what we're going to do here is we're going to use our calculator to give us our test statistics. So let me bring up the calculator, and I'm going to power it back on, and I'm going to go to second and stat. Whoops, not second, my apologies, just plain old stat. Let me quit out of here. Just going to go to plain old stat, over to tests, and I'm going to do a z-test. And I'm going to use it using the statistics. My mu was 40, and my standard deviation was 3.08. And my samples, what did I get for my samples here? 3.08, 39.2. So my sample average was 39.2. And I had 58 samples. 58. And my alternative hypothesis is not equal. So we'll calculate. And our z value is negative 1.978. And our p-value is 0.04. So let's put these two in here so we can look at both of these. So our z is negative 1.97. Make sure I pull everything across. Pull it back here. Negative 1.97. I'm going to keep the 8 for right now. And our p-value is 0.0479. 0.0479. Now, so we can see our p-value is less than our alpha value. So we should be falling into one of our critical regions, and we should be rejecting the claim. But let's do this. Let's find what our critical value is. Let's find what the critical value is of this line right here. What would be the z value of the first 3% of the data? So again, we're going to go back. We'll find z critical. It'll be a plus or minus because it's symmetrical across here. We're going to go back to our calculator, and we're going to calculate our z critical value. And we do this by going to second and distributions and down to an inverse normal. And we want to calculate what it would be to 0.03. Our standard deviation will be at 0. Our mean will be at 0, our standard deviation will be 1, and we'll paste this in. And this gives us a critical value of negative 1.88. Negative 1.88. 1.88. And so this is at negative 1.88. And so our test value does lie in the rejection region. So there is not enough evidence to there's enough evidence to reject the null hypothesis. And so there is enough evidence to reject the claim. If I get my wording correct there.